Good morning. I think we're about to start the last but the most interesting session of our conference. And the first presenter is Elena Kobzeva from a glorious city of Yekaterinburg. Please. Good afternoon. 3D models of territories or object is no longer exotic, but part of our life. 3D models available online are interesting for tourists. Cultural heritage 3D models are used for conservation purposes. Industrial sites in 3D are necessary for upgrading and reconstruction, as well as for forecasting and prediction. There are a lot of other examples I could cite. Such a variety of tasks for 3D modeling condition different accuracy, completeness, realism of 3D model, and that requires a variety of approaches. One of the most effective ways is photogrammetric method for 3D modeling based on photogrammetry processing of terrestrial, aerial, and space image data. In my presentation, I will show you an industrial project where a water reservoir was 3D modeled. Back in the 30s of the last century, the Academy of Science approved an ambitious project to reconstruct rivers to create deep navigational watercourse that would connect Black, White, and Caspian seas. And the idea was to create a cascade of water reservoirs along the Volga River. Originally, it was 11 water reservoirs, and the project had been more or less complete. But to date, 2 more hydro stations are not finished in Cheboksary and Nizhnekamsk. The modern water level is maintained at the 63-meter level. So, in 2009, the Russian government decided to complete Cheboksary hydro. My company was tasked to provide design I'm sorry.
Не трогайте. Some technical problems, небольшие технические проблемы.
Sorry for that. So we were tasked to provide maps for design effort. Next to conventional maps, we were supposed to create a 3D model along the impact area of the water reservoir. The purpose of the model was to illustrate visually the current status in the reservoir's impact area, the results of increasing water level to 68 meters, and to assess the efficiency of existing and proposed engineering solutions. This is the operational workflow we used. Aerial photography, creation of digital elevation models and orthophotos, obtaining mapping materials 1 to 10,000 for the whole territory and 1 to 2,000 for the territory of engineering protection. Generating 3D models of vital objects, synthesis of thematic information, and integration of heterogeneous data into one uniform 3D system. What technical means did we utilize? All photogrammetric activities, block adjustment, digital vision, model creation, orthophoto plans, stereo vectorization, all of that have been done on the basis of PhotoMod station. When it came to 3D modeling, we faced quite a few challenges because there were certain requirements. One of them is to support heterogeneous data, vector-based, raster, tubular data, various formats needed to be reconciled. Since the area was over 5,000 square kilometers, there was a storage constraint. And the cost issue, the price issue for creating a 3D model and the cost for further supporting and maintaining by us and other users was a factor. First, we tried to work in ArcGIS, Panorama, and other software, but then we decided to opt for SpaceEyes 3D. It made us happy. We were so impressed. We even included it in the list of products that we sell and the list of products that we use in training. So, how does our 3D model look? It follows a three-tier principle. The first tier is the general overview. The second level is a photorealistic representation of the most important parts of the territory, and the third level is modeling with details for certain sites and engineering protection zones. It all begins with a start page, 1 to 1 million scale, divided into 16 fragments. By selecting one fragment, city, or a section, the system goes into a more detailed level. The first level of detail is where general 3D model of the territory is presented. It provides you with the boundaries of the regions, settlements, communicates 3D models of unique objects, railroads, roads, hydrographic sites, and a few other. The second level shows you a better detailed picture of engineering protection sites and the 68-meter water level rise. The third level depicts detailed 3D objects all the way to lanterns and even the curbstones. Let me show you some of the fragments from our model. Remarkably, when the scope of works was being defined, we had a very general idea of what we want to get at the end of the day. Of course, we worked through the concept of a 3D model, but then, through iteration, in close cooperation with the customer, we worked out the details of the model, the level of detail of various areas, vector layers, thematic composition, textures, legend, signs, etc. And one more example. This information is extracted from our model. On your left, you can see the current water levels at 63.1 meter, and on the right we will see how the picture will change if the water level rises to a standard 68 meters. Also, we can see what happens if there is 1% flood affecting this area. 1% flood can occur once, the probabilities of it happening is once in 100 years. We can see that in both cases, the existing protective facilities perform their functions well. They protect both the city and the road crossing the river. So, originally, the 3D model was created for visual representation of the existing territory to see how water level rises will affect the area. After introducing the model into engineering processes of the customer, this system was upgraded to the status of interactive system that helped to address a lot of tasks and objectives of the customer. We are very happy that this system is in working mode and used extensively. It continues to be filled, and we continue to talk to the customer, and it is really being used quite actively in various departments and units of the company. Thank you very much. That is basically all that I wanted to share with you. Your questions?
Can I take a picture from here? Okay, thank you.
Can you give some non-cartographic attributes to your objects for spatial analysis?
Если не картографические применения или объекты, кто-нибудь может дать наушники?
Excuse me. Can I say it again?
Once more, please.
Give some non-cartographic attributes to your objects in your models for spatial analysis. Is it possible with this software, with this way to build your 3D models?
Yes, it is possible to give profiles in different formats, tables, graphic data from other formats. All of that is possible.
Which formats can you export your models?
I cannot answer this question. I know that it can be exported, but I'm not sure I know the format exactly.
Еще вопросы?
Any other questions? All right, then, thank you very much.